Assalamu alaikum. So in the last lecture we have discussed about addition polymers and how to make addition polymers, how to find out the structure of a monomer from the polymeric chain. So I hope everything is clear now. Now next we are going to discuss few questions from P1 and P2 on addition polymers, right? And then we'll start condensation polymerization, right? So first these are some questions from P1. Let's start with the question number 1. The diagram shows a section of a polymer, right? So we have a section of a polymer. This is the polymeric chain. Now the question is, which alkene is used to make this polymer, right? So that means we have to find out the structure of monomer. We have to identify which alkene is used to make this polymer. Right, so as I told you in the last lecture, that to identify the structure of the monomer from the polymeric chain, first we have to identify the repeating unit, right? So if I start the repeat from this carbon atom, so in addition polymers, we just have to take two adjacent carbon atoms in a polymeric chain to find out the repeat. So this would be the repeating unit. You can just simply see that the pattern is repeating itself again and again. So the same pattern, like this same pattern is repeated here, and this same pattern is repeated here. So that means this is our repeating unit. To identify the repeating unit in an addition polymer, this is very simple, right? Now let's just draw the repeating unit separately. So this is the repeating unit, C2H5H, H, right? And to convert it into monomer, just draw a double bond between the horizontal carbon atoms. So this would be the structure of the monomer. Now we have the structure of the monomer, and next let's just name the monomer, and then we can simply identify which of the options is correct. So how many carbon atoms do we have in the monomeric chain? 1, 2, 3, 4. These are 2 carbon atoms, C2H5. That means 2 carbon atoms present here. So that means we have an alkene with 4 carbon atoms, and double bond is on carbon number 1, carbon number 2, carbon number 3, and carbon number 4, right? Because so we have 4 carbon atoms in this structure, and double bond is between carbon number 1 and 2, right? So that means option A is not correct because we only have 3 carbon atoms in option A. Option C cannot be correct because it has 1, 2, 3, 4, 5 carbon atoms. Now it is either option B or option D. So in option B, you can see the double bond is between the first 2 carbon atoms, right? You can take it from left or right side, because in alkenes, numbering start from where the double bond gets the smallest number. So if I start the numbering in option B, if I start the numbering from right hand side, so this is carbon number 1, carbon number 2, carbon number 3, carbon number 4. So that means B is, if you look at the structure D, the double bond is between carbon number 2 and 3. So D could not be the correct option. So the correct option is option B. All right. So the next question is, the diagram shows the structure of polydichloroethene. This is the structure of polydichloroethene. N means it is a polymer. It has N number of monomers present. Which statement about this polymer is correct? Right, the monomer is, they have given us 4 options, and we have to find out which of these 4 statements is correct. In the first one, they're saying that the monomer is, they've given us the structure of monomer in option A and B. So let's just draw the structure of the monomer. You can see that the 2 adjacent carbon atoms, one of the carbon atoms has 2 hydrogens placed on it, and the other one has 2 chlorine atoms placed on it. So just to convert it into a monomer, we have to draw a double bond. So that means this would be option A, because in option A there are 2 chlorine atoms on the same carbon atom and 2 hydrogen atoms on the next carbon atom, and both the carbon atoms are double bonded to each other. Okay, so that means option A is correct. It is the correct monomer. In option B, you can see both the chlorine atoms are on the opposite carbon atom, so this cannot be the option. Option C is the polymer is formed by a condensation reaction. No, it is formed by addition reaction, because it is addition polymer. Addition polymers are formed by addition reactions. And option D is the polymer has a lower melting point than the monomer. And I have discussed the properties of polymers and monomers in the last lecture, and we have seen it that polymers have higher melting points. So option D can also not be correct. So option A is the correct option. Alright, so the next question is, the diagram shows the structure of a monomer used to make a polymer. So this is the structure of a monomer. What is the structure of the polymer? So again, because we have double bonded carbon atoms, that means it is an addition polymer. Now to draw the structure of the polymer, what we have to do, we have to break this double bond, we have to convert it into a single bond. Now this carbon atom has two hydrogen atoms attached to it, so 1, 2, and this carbon atom has two CH3 groups attached to it. So CH3, CH3, so this would be the repeat of the polymer. Now just look at the options and find out which of the option is correct. So in option A, we have this carbon atom attached with the two hydrogen atoms, and this carbon atom attached with two CH3, and the same thing is repeated on the next two carbon atoms. So that means option A is the correct option. Okay, so next question is, polyethene is the addition polymer formed from the monomer ethene. Which statement is correct? Polyethene is an addition polymer formed from the monomer ethene. Which statement is correct? Now we have four options and we have to find out which of these four options is correct. So polyethene can be disposed of by burning. This produces carbon dioxide and water. Now polyethene, what would be the molecular formula of polyethene? CH2, CH2, and this is polyethene. We have discussed it in the last lecture. Now it can be disposed of by burning. Burning means by reacting it with oxygen. Now as this polyethene is a saturated hydrocarbon, so this can also undergo combustion reaction, and on the combustion of a hydrocarbon we get carbon dioxide and water. So this is one way of disposing of the addition polymers, although it has its disadvantages, because the burning of a hydrocarbon it releases toxic gases in the air, right? So this is not a better way of disposing of the addition polymers, but this is one way of disposing the addition polymer. This produces carbon dioxide and water. So option is correct. Polyethene can be disposed of by burning. This produces carbon dioxide and water. So let's look at the other options as well. Polyethene decolorizes bromine water. This is the test for unsaturation. If you remember, we have discussed it in the last lecture that addition polymers, monomers can undergo this reaction, monomers of addition polymers, but addition polymers themselves, they are fully saturated. They are saturated, so they cannot undergo this addition reaction. They cannot decolorize bromine water. So option B is incorrect. Polyethene has the empirical formula C2H4. No, if you simplify polyethene, this is C2H4. If we simplify it, we get answer CH2. So this is also incorrect. Polyethene is acted upon by bacteria so that it decomposes quickly when in a landfill site. Basically, this is again incorrect, because polyethene, it contains large number of single covalent bonds which are very difficult to break. They have a high bond energy. They cannot be decomposed by bacteria. Only condensation polymers, they can be decomposed in this way, which we will discuss in the next classes. But this is an incorrect option. So that means option A is correct, that it can be disposed of by burning, produces carbon dioxide and water. Alright, G. So the next question is, in the polymerization of ethene from polyethene. Again, we have ethene from polyethene. Ethene to form polyethene. Which of the following does not change? Which of the following does not change? Boiling point, when we convert ethene into polyethene. Again, this is the question from the comparison of polymer and the monomer. So boiling point will definitely change. Addition polymer has higher boiling point. So polymer would have a higher boiling point. This is an incorrect option. As mass increases, density also increases, so this would also not be correct. Empirical formula, if you remember this thing, the empirical formula of monomer, this would be CH2, and the empirical formula of the polymer, this would again be CH2. So the empirical formula is similar, so option C is the correct option. Molecular mass, it increases, so option D is also incorrect. So the correct option is option C. Alright, next question is, the structural formula of a polymer is shown below. Now we have a structural formula of a polymer. Which of the following will form this polymer? Again, you have to find out the structure of the monomer, and again you will determine the repeating unit. And I hope now everyone knows how to find out the repeat. This is a repeat. This is the pattern which is repeating again here. So that means we have got a repeat. So the repeat is CH, C2H5, CClH. And to find out the structure of monomer, what we have to do is place a double bond here. All right. So now let's look at this. So in the structure, you can see that one of the carbon atom is attached to a hydrogen in C2H5. The other carbon atom is attached to a chlorine and hydrogen. So option B is not correct because option A is not correct because it contains 3 groups. So that is an incorrect option. Option B, we have C2H5 and Cl on the same carbon. So this is also incorrect. Option C, again we have C2H5 and Cl on the same carbon and no double bond. Option D, we have a double bond, a C2H5 and a hydrogen on one carbon atom, and a hydrogen and Cl on the other carbon atom. So that means option D is the correct answer. So it is very simple to find out the structure of the monomer from a polymeric chain. Alright, next question is, the diagram shows the repeat unit of a polymer. Now this is the repeat unit of a polymer. Which row correctly identifies the monomer and type of polymerization involves in making this polymer? So we have carbon-carbon atoms present in the chain, so that means it is an addition polymer, right? It is an addition polymer, so either it is option A or option C. Option B and D are not correct because they have given us condensation polymerization. So it is either A or C. And now if you look at the structure, how many carbon atoms do we have? 1, 2, 3 and 4, and a double bond placed between carbon number 1 and carbon number 2. So if you look at the structure, option D is incorrect because it has 1, 2, 3, 4 carbon atoms, but the double bond is 1, 2, 3 between carbon 2 and 3. If you look at the structure A, it has 1, 2 and 3, 4 carbon atoms, and double bond is between carbon number 1 and carbon number 2. So that means option A is the correct option because we have 4 carbon atoms and a double bond between carbon number 1 and carbon number 2. So option A is the correct option. Alright. Now next we have few questions from paper 2. Now they're saying that the structure of chloroethene is shown. They have given us the structure of chloroethene. We have drawn the structure of polychloroethene in the last lecture. Chloroethene is the monomer used to make polychloroethene. Polychloroethene is non-biodegradable. Alright, one thing you have to understand here is that addition polymers are non-biodegradable. Addition polymers are non-biodegradable. Right? They do not decompose on their own. They do not decompose by bacterial actions. And the reason is that they contain large number of strong covalent bonds which are difficult to break. They are non-biodegradable. They do not decompose on their own. And the reason for this is as they contain large number of covalent bonds which are difficult to break. Alright, which are difficult to break. So that means this is a disadvantage of addition polymers of plastics. Plastic do not decomposes on their own, right? So the disadvantages is first, one of the disadvantage we have discussed in the MCQ section in P1, that they can only be disposed of by burning, but it releases toxic gases, right? Burning releases toxic gases, and if not burn, then landfilling would occur. It occupies a large area of land which could be used for agriculture, for infrastructure, right? But it would be wasted in landfilling. So these are few disadvantages of using polymers. So polychloroethene is non-biodegradable. It is non-biodegradable. Explain the meaning of the term non-biodegradable. Now, what do we mean by non-biodegradable? Very simple question. Which do not get decomposed by bacterial actions. Alright, which do not get decomposed by bacterial action. Describe one environmental problem caused by the disposal of non-biodegradable plastics. So we have already discussed the environmental problems. You can write any one of those. It causes the burning of these. Burning releases toxic gases, or it causes landfilling, whatever, you can just write it here. Draw the partial structure of polychloroethene. Show at least two repeating units, two repeats. So polychloroethene, we have double bond between carbon atom and a chlorine atom attached to one of the carbon atoms. So to draw two repeats, just draw two carbon atoms, 1 and 2. Right now, one of the carbon atoms has Cl, this one also has Cl, rest are hydrogen atoms. Right, so these are hydrogen atoms. Now, because it is a polymer, so that means double bonds are broken, and now we have single bonds between these two molecules, and this chain is continued on both sides. So this is the structure of polychloroethene. Now, the next part of the question is that a factory uses 100 tons of chloroethene to make polychloroethene, right? They're using 100 tons of monomer to make polychloroethene. Reduce the mass of polychloroethene made. If they're using 100 tons, what mass of polychloroethene would be made? Assume the percentage yield is 100%. Explain your answer. So no calculations needed in this question. If you remember, I've discussed this thing with you in the last lectures, that nothing is added or removed in the formation of addition polymers, because what happens is that the monomers, they just simply add up to each other, right? And we get a larger molecule. So that means if we have 100% yield, nothing is wasted. So whatever is the mass of the monomers, if we have 100 tons of monomers, that means we get 100 tons of, we can get maximum 100 tons of polymer. Obviously, the actual yield would be less than that, but theoretically, what maximum amount of the polymer we can get, that would be 100 tons. So reduce the mass of polychloroethene. The mass of polychloroethene will be 100 tons, as it is an addition polymer. So nothing is added or lost. So whatever is the mass of monomer, we get the same mass of polymer. theoretically. Practically, we would get less than that because there will always be some sort of wastage. So we get less than that, but theoretically it would be 100%. All right. Now the next part, next question is, there is a concern about the disposal of plastics made from non-biodegradable polymers. So you can see that a lot of questions they are coming from the biodegradation of the polymers. The partial structure of non-biodegradable polymers shown. So this is again the structure of one of the polymer. This is same polychloroethene. Name the type of polymer shown. So what type of polymer is this? This is an addition polymer, because we have how to find out, how to identify that this is an addition polymer. We haven't discussed condensation polymers yet, but just remember this thing, that if you have an unknown polymer and you want to find out whether it is an addition or condensation polymer, just look at the backbone of the structure. If the backbone is made up of only carbon atoms, if the backbone is made up of only carbon atoms, that means it is an addition polymer, right? So we have addition polymer. Draw the structure of the monomer used to make this polymer. So again the same practice, the repeat is of 2 carbon atoms, right? So that means we have 3 carbon atoms in the repeat. 1, 2, 3. So 1, 2, 3, H, Cl. And for the monomer we have to draw the double bond. So this is the structure of the monomer. The polymer is often disposed of by combustion. State one problem associated with the method of disposal. It releases toxic gases in air. All right. 1,2-dichloroethene. 1,2-dichloroethene. This is ethene because it has 2 carbon atoms and a double bond, and because one of the chlorine is on carbon number 1, the other one is on carbon number 2. Therefore, name is 1,2-dichloro. Means we have one chlorine on carbon number 1, the other chlorine on carbon number 2, and ethene means it has a double bond. Is produced when excess ethine reacts with chlorine. The structure of 1,2-dichloroethene is shown. So this is the structure of 1,2-dichloroethene. Deduce the partial structure of the polymer of 1,2-dichloroethene. Show 3 repeat units. So we just have to draw the polymer which would form from this monomer, and we have to draw 3 repeats. So we just have to break the double bond, 1, 2, and 3. All right, next we have 2 chlorines, 1, 2, H, 1 chlorine, 2, H, Cl, H, and because double bond is broken, so that means now they have a single bond bonded to each other. Right, so this is the structure of the polymer which would form from 1,2-dichloroethene, and we have drawn 3 repeats. Repeat 1, 2, and 3. Now, next is product C can be polymerized to give the polymer shown. Again, we have a structure of a polymer. Draw the structure of product C. So all you have to do is place a double bond between these 2 carbon atoms. This is the structure of product C, or the structure of the monomer. All right. So this is the end of the practice session. I hope now you get the idea how to solve the questions on addition polymers. In the next lecture, inshallah ta'ala, we will discuss condensation polymers and then questions related to condensation polymers. All right. Allah Hafiz.